What happens when the most powerful space telescope ever built hands its data to a cutting-edge quantum AI?
What secrets appear when an algorithm scans the uncharted darkness between the stars?
Right now, that combination is rewriting everything astronomers thought they knew about comets, interstellar objects, and maybe even the building blocks of planets. This is the story of 3I/Atlas, a strange wanderer streaking through our solar system, and the quantum AI analysis that may change our view of the cosmos forever. In August 2025, astronomers flagged a faint moving dot in the outer solar system. Catalogued as 3I/Atlas, it was quickly confirmed as only the third known interstellar object ever detected, a body born in another star system that had drifted for eons before crossing our path.
Unlike a normal comet, 3I/Atlas carried a mystery in its glow.
Telescopes picked up a bright coma, the gas and dust surrounding its nucleus, but the composition looked. Even early ground-based spectra hinted at unusual chemistry. But those hints were nothing compared to what the James Webb Space Telescope, JWST, was about to reveal. If you've ever slipped on a pair of thermal goggles in a dark room, you know how the invisible suddenly leaps into view. Warm bodies glow against cold backgrounds. Structures appear where human eyes see nothing. That's exactly how JWST works, but on a cosmic scale. Its gold-plated mirrors and infrared instruments don't simply collect starlight, they read the heat signatures of dust, ice, and molecules billions of kilometers away.
Infrared isn't just another color. It's motion. It's the vibration of molecules, the swirl of dust, the slow sublimation of ancient ices.
Even the coldest comet far out in the dark can shine like a beacon in JWST's detectors. When 3I/Atlas crossed into Webb's line of sight, it didn't appear as a faint speck. It blazed across the detectors, releasing secrets no optical telescope could catch. Mission engineers swung JWST's near-infrared spectrograph, NIRSpec, toward the visitor. They started with prism mode, a low-resolution, wide coverage setting from 0.6 to 5.3 microns. Every photon from the comet's coma spread into a rainbow of chemical clues. The CO2 peak at 4.26 microns.
The water-ice bands.
The faint traces of carbon monoxide. Normally, comets show a gentle pattern, water dominating, CO2 barely a blip. But the raw data from 3I/Atlas came out like a heartbeat gone wild, lines rising and falling at impossible ratios.
The numbers weren't subtle.
The CO2 to water ratio hit nearly 8 to 1.
Most solar system comets hover below 1.
Even Borisov, the last interstellar wanderer, reached only about 0.5. For astronomers, that's like opening a familiar cookbook and finding the recipe written in another language. Here's where the story turns even stranger. The data was fed into a new quantum AI system, trained to sift through terabytes of JWST spectra looking for hidden structures, patterns no human eye could spot. The AI's analysis hinted at reservoirs of frozen compounds locked away since before our solar system formed. It mapped out plumes of carbon dioxide streaming from deep fissures, as if a buried ocean were venting into space.
This wasn't routine comet science. This was a message from another sun.
Infrared astronomy isn't about seeing objects the way we do with visible light. It's about reading their temperature, composition, and inner workings. A comet's coma comes alive in these wavelengths.
The hotter the outgassing, the brighter the signal.
JWST's sensitivity means every swirl of dust, every molecule of gas, every spark of heat stands out against the background. Where starlight blinds us to the faint, cold wanderers between worlds, heat vision reveals stories written in molecular fingerprints.
Algorithms don't get tired. They don't blink. They don't dismiss an anomaly as noise.
The quantum AI kept digging and found repeating intervals in the outgassing, almost like a rhythm, and subtle correlations between the CO2 spikes and the comet's rotation.
No one is claiming alien technology.
But the data may point to complex layering inside the object, perhaps a differentiated core, or chemical reactions frozen in time since its star system's birth. If such a body formed near the snow line of a distant star, then was ejected into interstellar space, it could preserve a chemistry unlike anything in our neighborhood. That partnership could soon reveal entire classes of interstellar visitors we've missed, or patterns in planetary systems that no telescope alone could decode. For now, 3I/Atlas is racing sunward, its coma expanding as it warms. JWST will continue to track it in multiple modes. Ground-based telescopes will compare visible spectra to the infrared. And the quantum AI will keep learning, refining its models, and maybe spotting echoes of the same signature in other data. The goal is to build a library of interstellar fingerprints, to know at a glance whether a visitor is cometary ice, planetary crust, or something entirely new. Each discovery nudges us closer to answering a profound question: how common are the seeds of planets among the stars? For viewers, this is your front row seat to a revolution in astronomy. The combination of JWST's heat vision and quantum AI's pattern recognition is peeling back the veil on the dark, cold spaces between suns.
Where human eyes find only darkness, these tools see motion, chemistry, and history.
So imagine, just for a moment, what secrets might still be hiding in the shadows of our universe, waiting for the right lens, and the right algorithm, to bring them to light. If discoveries like this excite you, make sure you subscribe and hit the notification bell. We'll be following 3I/Atlas as more data pours in, breaking down what the AI finds, and exploring what it means for our understanding of planet formation, interstellar travel, and maybe even life itself. Before we reveal the AI's next round of findings, we want to hear from you. Do you think algorithms will uncover structures in these interstellar visitors that no human ever could? Could we already be seeing evidence of cosmic processes we've never imagined?
Drop your guesses in the comments below.
The answers may change how we understand our place in the universe. Thank you for watching my channel.